Okay. Next rule is the following. This looks a little bit like the rule that we just did, but notice that a and m don't match, right? So this isn't just going to be r, but if you have a base here and a log there and you have an exponent, it doesn't really matter. You can just take it out. You can always write it this way. You can write it as r times the log a of m. And I will do a number example there right now so that you have some idea how that works. So if I had the log base 7, I'm using an awkward base, so it's not so easy to look for numbers or patterns here, of 20 to the power of 4, I can do one thing with that. I can put this 4 on the outside. I could say, well, that 4 could be here. So I could rewrite this as 4 times the log 7 of 20. And that's all that it is. It's just a trick to rewrite it. That comes in handy when you're trying to solve these things down the line, which we're going to have to solve these at some point. Not today. I'm just trying to mess with the properties today. Okay, so that's 1. And then we have one more, and that's called the change of base theorem, and you do not need to be able to prove it, but you ought to be able to use it. This is a tool that will allow you to use your calculator to find all of these, so something you will want to know. Can I erase this? Alright, let's start it. Okay, last one. This is not considered a proof because I'm doing this with numbers.
It's just the change of base theorem.
Yes.
Oh, I'm just going to know.
Change of base theorem is coming up. So, let's assume that y is equal to the log 3 of 8. Is that okay? Alright. Well, that means you can rewrite this. You can then write this as 3 to the power of y is equal to 8. Okay with that? We're going to use the last rule that I just showed you, and I am going to use the natural log here, and so that's something that we haven't seen a whole lot of, but I am going to take the natural log of both sides, and the natural log would be the log that has the number e as its base. Now I don't have to use, and I'll tell you in a moment why I'm using the natural log here, but you can use anything you want here. There is a good reason to use the natural log, and I'll show you that in a second. Okay, so if you do something on one side, so if I take ln3 of,
Is that an E or an L?
that's an L, and then I have to do it on this side, so I'm just applying the log. It's like taking a square root on both sides. Okay, so what I'm sort of doing is the equivalent of this. If I knew that 3 squared is equal to 8, I would take the square root, I would have to have an x here, wouldn't I? If I knew that x squared was equal to 8, I would take the square root on both sides to solve this to get x is equal to the square root of 8. That's sort of the thinking that's going on here, except I'm using logs. The last rule that that I showed you dealt with this y. What can you do with this y? Right, so stick it out in the front. It's the same thing as writing y times ln3 is ln8. Okay, let's solve this for y. So y has to equal what? ln8 divided by ln3. Keep in mind that ln8 and ln3 are just some number. They're worth something. ln3 being close to 1, because e was 2.72. Okay, what did I say up here y was worth? Alright, so log 3 of 8 is also worth y, so doesn't that mean that log 3 of 8 has to be ln8 divided by ln3, since they're both worth y? They both are worth y, so they must be equal to each other. Okay, if I'm telling you that x is 4 and that you're worth x, how much are you worth? 4. So I'm telling you here y is ln8 3, then you can equate these two. Okay, how does this help you? If you have your calculator with you, on your calculator there's an ln button. There's no log 3 8 button. But if you want to know what log 3 of 8 is worth, you stick into your calculator the natural log of 8 divided by the natural log of 3, and that will give you your answer. And that's why I picked ln. I could have picked log base 10, but I haven't introduced that one at all, so I'm using ln today because we have at least talked about it a little. Okay, so this allows you, rewriting this, you have an ln button on your calculator. ln is on the calculator. So you can actually find the answer for that. So the change of base theorem, I'll rewrite one more. So let's say I have a log 5 of 2. Okay, what would that be? Well, let's see the pattern here. We had a log 3 of 8. So log 3 of 8, the 8 goes in the top, the 3 goes in the bottom. So where does the 5 go? 5 should be in the bottom, and the 2 goes, okay, and so I can pick any base that I want. So for example, I could have picked log base 10 of 2, which happens to be on your calculator as well. Or I could have picked, this is the same thing as saying ln 2 divided by ln 5, which I'm lazy, that's less writing, so that would have been another good one to use. That's what it's useful for. Okay. Can I clear this page? Okay. So here's some examples of things that I've talked about today. So we should now be able to solve this. What's the log 5 of 5 to the third? It's 3, because this base and that base matches, so that's 3. Okay. The last rule was this, log, I would just stick the 3 on the outside, but what's log 5 of 5 worth? 1. So this actually shows you sort of two rules. It's a combination of two things here that makes this worth 3. Log 5 of 5 is actually 1. So, and 3 times 1 is 3. So you can do that in one step. How about ln e of pi? What is the base for a natural log? The base for the natural log is e. The bases matches. The base match. So what do you get? Just pi. What about this one? The log 4 of 12 minus the log 4 of 3. We should be able to solve this now. I'll show it step by step. So
Is that second log an exponent? Log 4 and to the power of log 4.
yeah. What was your question?
I said, is that second log?
This one?
Or wait, is that an exponent or just?
No, it's just log base 4 of 3. Sorry. So Josh said that this is the log base 4 of 12 divided by 3. Okay, what is 12 divided by 3?
4.
And log 4 of 4 is worth? 1. So you can solve it. Okay, we can do the same thing if we had like a multiplication. So if this was log, and we'll change the numbers, log 12 of 4 plus the log 12 of 36. Thanks. So if it's an addition, you can write it as a multiplication. So 4 times 36. You would get a calculator. What is 4 times 36? 144. Can you recognize 144 as a power of 12? It's 2, right? That's 2. 12 squared would be 144. So you can solve it. Only if, you know, the things match. And so this is sort of the puzzle here, is can you make things match is sort of the trick. Can I erase these?
No.
Let me know when you're done. Okay, I got one left, really.
Okay.
So some of you are still copying. You done, Tanya?
Yep.
In the back, you done? Copy? Okay. Here's a rewriting exercise. So, what is the log 4 of 2x divided by 5? How can I rewrite that? If you have a division, you can rewrite it as a the other one, right? Subtraction. Remember, this is like tied to exponents. When you divide, what do you do with your exponents? You subtract. Try to tie it back to exponents. You know those rules already because you've been working with them since like 8th grade. This is the first time you're working with logs, but logs are exponents. So same rules apply. Just they look really weird because it's log 4 or 5, whatever that is. Okay. What if I wanted to use a calculator on that? I can't do anything with this yet. So how else could I rewrite this? So I'm looking for like a change of base. So I'm going to use ln's because it's on the calculator and we've talked about it. So rewriting this one would be what? The 2x goes on the top, and then ln 4 would have gone here, minus ln 5 divided by ln 4. Okay. In case you're wondering why would you do this? Well, if this was a function, now I can put it in my calculator and I can actually graph this. Because ln 4 is worth something, it's slightly more than 1. ln 5 divided by ln 4 is worth something, so that's a number. So this is going to end up being very much like ln 2x divided by 1 minus 1. Because that's all that you have. These things here are worth numbers. So in essence, this becomes like a problem that you already have familiarity with, except it's in logs, so it's weird. Okay, that's it. Anybody have any questions? I gotta show you your homework. It's a little odd.